in this question, it looks like we need to do some partial fraction analysis, but you'll notice that the order of the numerator is 2 and the order of the denominator is 2, meaning the highest power in the numerator is 2 and the highest power in the denominator is also 2. And if the order of the numerator and the denominator are the same, you can't simply do that. You need to carry out long division to find the value of a. Okay, so before we do any partial fraction analysis, we need to do long division or polynomial division. So we divide the numerator, 2x squared plus 5x minus 10. We divide it by the denominator. Now, denominator is no good in that form. Let's expand that. That will give you x squared plus x minus 2. So we put that here. And then you divide. Now remember how to do polynomial division? You look at the term with the highest power. So you'll be looking at the 2x squared and the x squared. And if you divide this by that, you'll get a quotient of 2. And then you multiply all of these, because what we're looking for is the remainder. So you multiply that, and you'll get 2x squared plus 2x minus 4. Now, if you subtract, 2x squared minus 2x squared is 0. 5x minus 2x, remember we're subtracting here. 5x minus 2x is 3x, and minus 10 minus minus 4, so that's minus 10 minus minus 4 is minus 6. And you can't divide that by that, so this is your remainder. So the quotient is 2, and this is your remainder. So the quotient is a. So we've already found the value of a. Now we're going to use the remainder in order to find b and c. So we can write this this fraction as 2 plus the remainder, which is 3x minus 6, divided by x minus 1 times x plus 2, which is just this. So our partial fractions problem now becomes rewriting this in terms of b and c. Because we've already found a, which is the quotient after doing the long division. So the remainder goes up there, and we use this remainder to find b and c. So let me make some space. I can now do the conventional partial fractions. Analysis, so I'll say b times x plus 2 plus c times x minus 1 equals 3x minus 6. So this is your numerator there, which was the remainder. And then you just choose appropriate values for x. So to make that 0, I'd say x equals 1. Then substitute 1 here. And so if you substitute 1 here, here, and here, you get 3b, that is 0, equals minus 3. So b equals minus 1. And if you set that to 0, we'll have x equals minus 2. And substitute that there, there, and there. You'll get minus 3c equals minus 12. So c equals 4. So now we've found b and c. We can replace these with minus 1 and 4. So that would be your final answer for the partial fractions, except we generally don't like having a plus and a minus, or we don't like having minus signs in the numerator. So you could just remove that and replace it with a negative sign there. So that's a nicer way of doing that partial fraction. So this is your final answer for the first part. It says find the value of the constants a, b, and c. So the answer would look something like this. A equals 2, b equals, what was it, minus 1, c equals 4. Then it says, hence or otherwise, find the exact evaluation of this integration. So it's the same, but there are limits from 0 to 2. So rather than integrating this, we would really want to be integrating that. So we can jump straight into that and say, well, if we're going to integrate, let's just integrate from 0 to 2 dx this, because this is much simpler and it's essentially the same question. So we can integrate each of these separately. So what's the integral of 2? That's simply 2x. What's the integral of 1 over x minus 1? It's simply log x minus 1, or natural log. Make sure you don't forget the minus sign. And the same here, it's plus 4 times log x plus 4. Okay, so that's your answer, but because it's a definite integral, you need to add the limits from 0 to 2. So we'd substitute 2 into each instance of x, and then substitute 0, and then subtract one from the other. So it's 2 times 2 minus ln 2 minus 1 plus 4 ln 2 plus 4 minus 0 minus ln absolute value of negative 1 plus 4 ln 4. Okay, so were it not for this absolute value, we'd have a problem here because you can't take a log of a negative number. So now we can just simplify that to 4 minus ln 1 plus 4 ln 6. Now make sure you multiply the negative 1 by each of these. So the sign for each of these will change. sorry, so this sign will change and this sign will change. This is absolute value, so log minus 1, we'll write that as minus or plus log 1. So this minus times minus gives me plus, and the absolute value of minus 1 is 1. And then minus 4 ln 4. Now, ln 1 is just 0. So you end up with 4 plus log 6 minus 4 ln 4. So unless I've made a mistake somewhere, that's your final answer. They wanted an exact value, so that's your exact value. You could, if you want, combine these two logs into one, or you could just leave it like that.